Today we shall discuss about the 8th standard geometry chapter understanding quadrilaterals. So students, in the previous classes you have studied about basic concepts of the geometry, that is point, line segment, angles, types of angles, triangles and types of triangles. So now we will study in further types of the plane figures. So that means quadrilaterals. So in this chapter we will see the contents you are going to study are: first one is the introduction, second one is polygons, third one is classification of polygons, diagrams of the polygons, convex and concave polygons, regular and irregular polygons, angle sum property. And lastly, we will study the types of quadrilaterals. That means the different types of quadrilateral. So we are going to study them. Students, before going to study the chapter, so you observe the given the plane figures. So you might have studied and also you might have seen these type of shapes in your daily life. So observe this. So this we call this as a globe. So this is a circle. So this is a triangle. Students, name this plane figure. Yes, it is a square. So this one is rectangle. So this one is parallelogram. This one is trapezium. This one is rhombus. And observe this last plane figure. So if you observe the last plane figure, so first this has a 3 sides. It has a 4 sides. This has also 4 sides. It has also 4 sides. So all these solids, so what I am indicating you, so showing you, they have the 4 sides. So if you observe this, so it has the sides 1, 2, 3, 4, 5, 6. So this has 6 sides. So you might have all seen this type of plane figures in your day-to-day life. Okay, students. Students, the word polygon. So the word polygon has, if we observe the word polygon, it consists of 2 words, poly and gon. So poly means many, gon means sides. So in generally we can say that polygon means, so it is a plane figure which consists of more than 3. So 3 or more than 3 sides. More than 3 sides. Polygon means, poly means many, gon means sides. So many means it must be 3 or more than 3 sides. So by the definition of the polygon, a simple closed curve made up of only line segments. So it is a simple closed curve. So that means, so observe here this plane figure. So here it is a closed, the curves are closed. So closed curves made up of only line segments is called as polygon. So for example, if you observe these figures, so here the line segments are closed. The line segments are closed. This type of plane figure is called as polygon. Students, now we shall see the classification of polygons. So polygons are classified on the basis of their sides, depending upon the number of sides. Students, so we shall see the classification of polygons. So polygons are classified according to the number of sides that they contains or number of vertices they have. So if you observe the classification of the polygons, so observe here the number of sides or vertices. So classification or name of the polygon. So samples figure of the given polygon. Students, if the polygon has 3 sides or 3 vertices, it is called as triangle, which is you have already studied in the previous classes. So that means a plane figure which is bounded by 3 sides is called as a triangle. So this is a sample figure of the given triangle. So next, if the polygon has 4 sides, so it is called as quadrilateral. So this is the sample of only the sample figure of the polygon quadrilateral. So if the polygon has 5 sides, so it is called as pentagon, or it is named as pentagon. So if you observe this figure, so this figure has 1, 2, 3, 4, 5. So 5 sides. So therefore it is called as pentagon. So if the polygon has 6 sides or 6 vertices, it is named or it is called as hexagon. So if you observe this figure, so the sides are 1, 2, 3, 4, 5, 6. So therefore it is called as hexagon. So similarly, if the polygon contains 7 sides, it is called as heptagon. So that means it has 7 sides. So if it contains 8 sides, it is called as octagon. So if it contains 9 sides, it is called as nonagon. So if it contains 10 sides, it is called as decagon. Similarly, so it may continuous in the way. So if it contains n sides, it is the polynomial is called as n-gon. So n, if it contains n sides, it is called as n-gon. Students, so here, so if a polynomial has 3 sides, it is called as triangle. Polygon contains 4 sides, it is called as quadrilateral. If a polygon contains 5 sides, it is called as pentagon. If a polygon contains 6 sides, it is called as hexagon. If it contains 7 sides, it is called as heptagon. 8 sides is called as octagon. 9 sides is called as nonagon. 10 sides is called as decagon. So similarly, it will goes on continuously. So if the polygon contains n sides, it is named as n-gon. Students, now we shall see the diagonals of the polygon. So diagonal means, a diagonal is a line segment connecting 2 non-consecutive vertices of a polygon. How to understand the definition of the diagonal? So diagonal means, so it is a line segment, so which connects. Diagonal is a line segment which connects 2 non-consecutive vertices of a polygon. So, for example, so if you observe this plane figure which contains, so this is a polygon which contains 4 sides. 1, 2, 3, 4 sides. So that means it is a quadrilateral. So here, so AB, BC, CD and DA are called as the sides of the given polygon. AB, BC, CD and DA are the sides of the polygon. So because they are the line segments joining the adjacent or consecutive vertices. So here A is connected with B and B is connected with C and C is connected with D. D is connected to vertices A. Therefore, AB, BC, CD and DA are called as sides. So, in case by the definition of the diagonals, so observe the line segments A, C. So this line segments. So AC is a line segment. So which connects the opposite vertices or non-consecutive vertices. So A and C are the opposite vertices or non-consecutive vertices. So therefore AC is a diagonal. Similarly, DB is also a diagonal. DB is also a diagonal because D and B are the two non-consecutive vertices. So, do you understand the definition of the diagonals of the polygon? Diagonals of the polygon means, so it is the line segment which joins, so which connects the two non-consecutive vertices of a polygon. From the first figure, AC and DB are the diagonals. In the second figure, so this is a polynomial. Students, shall you name this plane figure? So on the basis of the sides, it has 1, 2, 3, 4, 5. So it has 5 sides. So what do you call this polygon? Yes. So it is a pentagon. So it is a pentagon. 1, 2, 3, 4, 5. So it is a pentagon. So A, B, C, D, E, A is a pentagon. So in this pentagon, it has a 5 sides. The sides are, so observe carefully, the sides are AB, BC, CD, DE and EA. So whereas coming to the diagonals, so it is a line segment. It is a line segment which connect the non-consecutive vertices. So this point to be remembered. So two non-consecutive vertices. So observe in this figure, A connected to C, AC, A connected to D, AD. So similarly, B to E, B to what is this? D. Similarly, C to A, C to E, and the same way D to B, D to A, so E to D, E to C. So these are all called as the diagonals. These are all called as diagonals. So therefore, in this polygon, pentagon, so AC, AD, BE, BD, CE and DE, and So this is a pentagon. In this pentagon, so the sides are AB, BC, CD, DE and EA. So in this pentagon, so if we going to write the diagonals, that means A, what is A is connected to what is C, A is connected to D, so B is connected to E, and what is this B is connected to D, C is connected to A, and C to E. Similarly, D to B, D to A, E to C, E to B. So therefore, in this pentagon, the diagonals are AC. AC is a diagonal, AD is a diagonal, BE is a diagonal, BD is a diagonal, and CE is a diagonal. So these are the diagonals of the pentagon. Students, now you have to observe the last figure. So shall you try to write the diagonals of this last plane figure? So shall you have to name this figure. Name this figure P, Q, R, S, T, U. This has P, Q, R, S, T, U, P. P, Q, R, S, T, U, P. So this is has 1, 2, 3, 4, 5, 6. So 6 sides. So therefore, it is called as a hexagon. So that means it has a 6 sides. So students, try to write the diagonals of this low plane figure or hexagon. So try to write yourself also. So you are already confirmed with the definition of the diagonal. Definition of the diagonal. Diagonal means, so it is a line segment which connects. It is a line segment which connects the opposite vertices or so two non-consecutive vertices. So I will show one or two, P and R. These are the non-consecutive vertices. PR is a diagonal. Similarly, from P, PT is a diagonal. Similarly, PS is a diagonal. So let us try this to. Now we shall study the regions of the polygon. So regions means bounded area. So polygon has two regions. Polygon has two regions. First one is interior region and the next one is exterior region. So interior and exterior region. So if you observe these two figures, these two figures. So the area which is inside this bounded region, so it is called as the interior region. The area which is closed or bounded. So the interior part is called as interior region. So this interior region of the polynomial, so it has a boundary, it has a limitation, it has a boundary. So this is the inner part. That means in generally we can say that the inner part of the inner part region is called as interior region. So coming to the exterior region, so the outside of the polynomial, outside region of the polynomial is called as exterior region. So the interior bounded part of the polygon is called as interior region. So and the outer part of the polygon, is called as exterior region. This is an exterior region. So if you observe these two polynomials, so this interior region has a boundary. So that means it has a limitation. It has a limitation. So whereas in case of exterior region, so it has no boundary. So there is no limit. There is no limit for the exterior region of the polygon. So understand, students? So now we shall see the types of polygons. So in the types of the polygons, regular polygons and another one is irregular polygons. So coming to the regular polygons, so regular polygon means, so it is a polynomial, it is a polygon, sorry, it is a polygon that is a equiangular and equilateral. So it is a polygon which is equiangular. That means all the angles of the given polygon are equal. So they have the same measurement. And equilateral. So students, observe here. So regular polygon means polygon that is equiangular, and the character is equilateral, equiangular and equilateral. So equiangular means all the angles of the given polygon must be equal, and all the sides of the given polygon must be equal. So such type of polygons are called as regular polygons. So polygon that is equiangular and equilateral are called as regular polygons. So regular polygons have their sides are equal. They have the equal sides and all the angles are equal. So understand? So regular polygon means, so polygon which has an equiangular and equilateral. That means it has all sides must be equal in that polygon, and also all the angles must be equal. So students, observe these two figures. So these two are the regular example for the regular polygons. So this is a, students, name this plane figure. Yes, this is a triangle. So observe this triangle carefully. So if you observe this triangle carefully, so here in this triangle they have given that all the three sides are equal. So if all the three sides of a triangle are equal, so then it is called as, what do you call such type of a triangle? So it is called as equilateral triangle. Yes. So it is an equilateral triangle. So it is an equilateral triangle. So students, you are also familiar with the properties of the equilateral triangle. So in an equilateral triangle, all the sides are equal and all the angles are equal to 60 degree. All the interior angles are equal to 60 degree. So therefore, it is a equilateral triangle is an example for regular polygon. So students, now observe the second diagram. So here, if you observe this, so here it has a four sides, 1, 2, 3, 4. So it is called as quadrilateral. So if you observe that quadrilateral, So 1, 2, 3, 4. All the four sides are equal. So in this diagram, all the four sides are equal. And also, if you observe the angles, so all the angles are equal to 90 degree. That means all the sides are equal and all the angles are equal. So let me tell me. So if a plane figure or if a quadrilateral having the all the four sides are equal and all the angles are equal. Yes, yes. It is a square. Exactly, it is a square. So, square is also an example for the regular polygons. So, students, I think you have clear about the regular polygons. Regular polygons means so those polygons which have equiangular, that means all the angles of the given polygon must be equal and all the sides must be equal. So coming to the irregular polygons. So the name itself says that it is an irregular polygon. So that means so it has not a regular polygon. That means the sides may be equal or may not be equal, and the angles may be differ from one angle to another angle. So therefore, irregular polygon means so they are the not regular polygons. That means so they have different length of sides. So different length of sides, and also each interior angles have different measurement. Each interior angles may be different measurement. So in case of irregular polygons, so they can have the different length of sides, and also their angles may be their measurement may be different. So if you observe these two figures, so first figure, what do you call this figure? Yes, it is a triangle. Okay, so it is a triangle. If you observe it carefully, so these two sides are equal. So in a triangle, if two sides are equal, then it is called as, what do you call that? So it is called as isosceles triangle. Isosceles triangle. So it is an isosceles triangle. So and in an isosceles triangle, so only two angles are equal. So therefore, this isosceles triangle is an example for irregular polygon. Similarly, observe this another figure. So it is a quadrilateral. So in this quadrilateral, so if you observe carefully, the opposite sides are equal, but not all the sides. Opposite sides are equal. So therefore, it is an example for irregular polygon. But if you observe the angles, all the angles are equal. Angles are equal, but the sides are not equal. Therefore, it is an irregular polygon. So, can you name this figure? So, the quadrilateral, so which has opposite sides are equal and all the angles are equal. So, it is called as a rectangle. It is called as a rectangle. So, therefore, students, so you have to kept in mind that irregular polygon they may have and sides in the different length or the angles in the different measurements. So whereas in case of regular polygons, so they must have all the sides are equal and all the angles have their equal measurements. Students, now we will see the another types of polygons. So that is concave polygon and convex polygon. So concave polygon means, so this type of polygons, they describes the shape that curve inward. That means you have already familiar with the convex and concave lenses. So the shapes, these shapes, they are, so they curve inward like an hourglass. So which is in our glass hour, this type, in this shape, the curve is inwarded. The curve is inwarded like an hourglass. Hourglass, that means a watch. If you observe the watch. So in such a way, the curve is inverted in this concave polygons. So the angles, so it has a reflex interior angle. So reflex interior angles means students, you are already familiar with that. So the angles lie between 180 degree and 360 degree. Therefore, students, so try to understand the concave polygon. So this type of polygons have the shape curve inward. So they have a curve inward like an hourglass. So the interior angles, they are the reflex angles. They are the reflex angles. That means the measurement lies between 180 degree and 360 degree. So example, if you observe these two polygons, so it is a polygon, so which has a four sides, so it is a parallel. So this is a rectangle. So these are the examples for the concave polygon. So if you coming to the convex polygon, so here this shape describes curve outside. So curve, so it should be, curve should be outward. So like a football. So have you feel the football? So the curve will be outward. So all the interior angles must be less than 180 degree. Here the interior angles are less than 180 degree. So observe these figures. So this type of figures or polygons are example for the convex polygons. So concave polygons means the of the uh, shape of the curved figure, it describes the shape that curve inward like an hourglass, but here the shape will be, that means the curve will be outward like a football. So here the interior angles are reflex, that means so it lies between 180 degree and 360 degree. So whereas in case of convex polygon, all the interior angles must be 180 degree. So the example for this concave polygon are these, and the example for the convex polygon are those. So now, students, so today we have discussed about the polygon, definition of the polygon, so classification of the polygon, diagonals of the polygon, and the special types of the polygons. That means uh, regular and irregular polygons, and the concave and convex polygons. Now students, by so understanding these concepts, so you have to simplify the exercise 4.1, the first main of the exercise 4.1, that will be given as a homework. homework for you. Students, so now we shall see the angle sum property. That means, so we will find out the sum of the interior angles of the given polygon. Now we will see the sum of the interior angles of the given polygon. So observe this figure, students. So this is a three-sided plane figure. It is called as a triangle. That is, you have already studied so in the previous classes. So it has three sides. It is called as triangle. So all of you know that the sum of the interior angles of the triangle is 180 degree. So therefore, for this plane figure or a polygon, so it has three sides. So it is a triangle. The sum of these three interior angles must be equal to 180 degree. Therefore, angle sum equals 180 degree. So this can be written as 1 into 180 degree. 1 into 180 degree. 1 into 180 degree. Students, so we are going to, if we want to find out the interior angles of the different types of the polygons, we have to know the triangles, number of triangles. So on the given polygon. So if you observe the second figure, so it has a four sides. So it is called as a quadrilateral. It is called as a quadrilateral. So it has four sides. So if you convert this quadrilateral to the triangles, so that means if we draw a diagonal, so one diagonal, it is converted into two triangles. So a quadrilateral is converted into two triangles. So the sum of the interior angles of one triangle is 180 degree, another triangle is 180 degree. So 180 plus 180, 360. So similarly, on the same way, so this quadrilateral has four sides. So that means it will be two triangles. Therefore, the sum of the interior angles must be equals 2 into 180 degree. So this can be written as 4 minus 2 into 180 degree. Now, students, observe this figure. So it has five sides: A, B, B, C, C, D, D, E, and A. So this is if a polygon has five sides, it is called as. So what do you call if a polygon has five sides? It is called as, yes, it is a pentagon. So if you observe this pentagon, so here the triangles formed in interior part of the pentagon. One, this is A, B, C is one triangle, A, C, D is another triangle, and A, D is another triangle. There are three triangles. Therefore, there are three triangles are there. So therefore, so the sum of the interior angles of the pentagon is 5 into 180, sorry, 3 into 180 because there are three triangles are formed. So sum of the each interior angle is 180 degree. So students, observe clearly, if we want to calculate the sum of the interior angles of the given polygon. So we have to convert that given polygon to the triangles. So depending upon the number of triangles, we are going to multiply it by 180 degree. So in the first figure, it is a triangle, three sides, its interior angle is 180 degree, so it can be written as 1 into 180 degree. So in a quadrilateral, it has four sides, it has two triangles, so therefore its interior angle is 2 into 180 degree, so it can be written as 4 minus 2 into 180 degree. So in this pentagon, there are three triangles are there. So therefore, its interior angle must be 3 into 180 degree. So it can be written as 5 minus 2 into 180 degree. Similarly, ಹೀಗೆ ಬರಿತಾ ಹೋಗ್ತಾರೆ. So ಹೀಗೆ so if you go on writing like this, similarly for a polygon having n sides have n minus 2 into 180 degree, n minus 1 2 into 180 degree. Therefore the sum of all interior angles of a polygon, so having n sides, that means we are going to conclude. So if a polygon contains n sides, so the interior angles must be equals n minus 2 into 180 degree. N minus 2 into 180 degree, we are going to substitute in place of n 3, 4, 5, etc. and so on. Students, now we shall see how to find out the sum of the exterior angle, that means outer part of the given polynomial. So that means sum of the measures of the exterior angles of a polygon. So here I have taken an hexagon. So A, B, C, D, E, F, A. So 1, 2, 3, 4, 5 and 6 sides. So therefore it is called as an hexagon. So if you extend this each sides of the given polygon, so that means the side AB is extended, BC is extended, CD is extended similarly. So the angles which are formed here, they are the exterior angles of a polygon. So these are all the exterior angles of the polygon. So whereas in case of A, B, C, D, E, F, so these are the interior angles of the polygon. Already you have learned how to calculate the sum of the interior angles of the given polygon. So now, the exterior angle, so it is fixed. The exterior angle of the given polynomial is, so it measures the sum of the measures of exterior or external angles of any polygon is 360 degree. So this is true for the number of sides of any sides of the given polygon. Any number of sides of polygon. So it may be the quadrilateral or pentagon or hexagon or heptagon, any type. So therefore the sum of the measures of external angles, so the external angles of a polygon is always 360 degree. So I have to understand this, students. Okay.